Today, we're going to talk about something that sounds, well, completely backwards. How do you secure a powerful new AI? By intentionally training it to fail. Yeah, you heard that right. It's a really weird question, isn't it? I mean, we spend all this time and energy trying to make AI smarter, faster, more accurate. So why on earth would you teach it to be wrong on purpose? Well, it turns out the reason is pretty brilliant, and it solves a massive problem. Okay, so to really get why this is such a big deal, we need to zoom out a bit. Let's talk about the incredible and, yeah, incredibly expensive world that even created this problem to begin with. Look, the whole quantum era thing, it's not sci-fi anymore. It is here. We've got companies like IBM and Atom Computing building these monster processors with over 1,000 qubits. We're talking about machines that can tackle problems that would make even the world's best supercomputers just give up. And one of the most exciting places this is all happening is in AI. Think about a quantum neural network, or a QNN. It's kind of like the neural networks we have now, but it's been supercharged with all the weird, wonderful physics of quantum mechanics. The potential here is insane. These things could learn and process information in ways we can barely even wrap our heads around right now. But, of course, there's a catch. There's always a catch, right? To build and train one of these game-changing AIs, you actually need a quantum computer. And that hardware, well, it's not just rare, it is astronomically expensive to build, let alone operate. So for pretty much everyone, that's a huge wall to climb. So that scarcity creates a real dilemma. And it leads to a solution that honestly should sound super familiar if you've been paying attention to tech at all. Yep, the solution is the cloud. It's the answer to everything, right? Just like we rent server space from AWS or Google, the future of quantum AI is all about quantum machine learning as a service. This means companies and researchers can just rent time on a quantum computer instead of trying to buy one themselves. It makes perfect sense. But this opens up a brand new and honestly massive security hole. See, when you run your model on someone else's computer, they have what we call white box access. And that means exactly what it sounds like. The cloud provider can see everything. Your model's architecture, all its parameters, your entire secret sauce is just sitting right there for them to look at. So there it is, the big dilemma. On the one hand, the cloud is fantastic. It democratizes access, lets way more people get in on the action and innovate. But on the other hand, what if the cloud provider is a little shady or just gets hacked? They could straight up steal your model, all that intellectual property you poured millions into developing. Poof, gone. And this isn't just some theoretical risk. We're talking about a high-stakes digital heist that could seriously slow down the quantum revolution before it even gets off the ground. Which brings us right back to where we started. How in the world can you build the future on hardware that you can't fully trust? And the answer, like we said at the beginning, is pretty clever. You fight deception with more deception. So let's talk about the solution. It's a technique called STIQ. That's STIQ. It stands for Safeguarding, Training and Inferencing of Quantum Neural Networks, which is a mouthful, I know. But the trick itself, it is fascinatingly clever. Okay, so here's how it works, step by step. First, instead of sending one AI model to the cloud, the user sends two. Now here's the key. Both of these models have been specially trained to give a deliberately wrong answer. You could say the answer is obfuscated. Then once those two wrong answers come back to the user's own private computer, a little local program combines them. And what happens? The single correct prediction pops out. It's kind of like having two halves of a secret key. Each half is useless on its own, but put them together and you've got the whole secret. So let's put on our spy hat for a second. What would someone snooping on the cloud server actually see? Well, if they managed to steal that first model, QNN1, it would confidently spit out an answer for them that is completely and utterly wrong. To the spy, this expensive, powerful AI would just look broken. All right, what if they steal the second model, QNN2? Same story. It also gives a confident but totally wrong answer. And here's the crucial part. It's wrong in a different way than the first one. So to any spy trying to steal your work, both of these incredibly valuable AI models just look like a pile of useless garbage. But here is where the magic happens. When the user gets those two misleading results back on their own secure machine, that local program combines them. The errors have been specifically designed to cancel each other out. And what's left? The true, highly accurate answer is revealed. It is the perfect example of two wrongs actually making a right. The whole security of the system relies on the fact that no single piece of the puzzle sitting on that cloud server is valuable by itself. And the numbers absolutely back this up. If you steal just one of the models, its accuracy plummets by an average of 70%. Think about that. It's not just a little bit inaccurate. It is functionally useless to anyone who steals it. Now, of course, there is a trade-off. Running two models instead of one means you're using up to twice the computing power. But as the researchers point out, that's a pretty small price to pay when you're securing intellectual property that could be worth millions or even billions of dollars. So the big question is, does this clever security trick hurt the final performance? And the data shows a crystal clear answer: nope. When you compare a normal unsecured model to the final combined STIQ model, the accuracy is pretty much identical. So you're getting all of that security with basically zero downside to your performance. That's huge. So why does any of this really matter? Well, a technique like STIQ does way more than just protect one company's secrets. It helps build trust in this whole quantum cloud idea. And when there's trust, more people are willing to experiment, it lowers the risk for startups, and it really does help democratize access to this incredible technology for everybody. And all this leaves us with a pretty fascinating thought to end on. As more and more of our really critical digital stuff, from AI to our finances, gets built on shared hardware owned by somebody else, you have to wonder, is creative, intentional deception like this going to be the new gold standard for cybersecurity?